I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it, and that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. This podcast is brought to you by Jarhead Diagnostics. Jarhead Diagnostics manufactures in-house diagnostic equipment and storage solutions, as well as distributes for companies like Pico, ATS, and TopDon. One of my favorite tools that I've bought from Brandon and Jarhead Diag is the case for the U-Scope. If you don't have a U-Scope, you probably should, but if you have one, you got to get one of these 3D printed cases, has a magnet on it, has a full-size BNC lead that you can connect to, and it gets rid of the weak point of that scope, which is the mini BNC connection, which is pretty fragile. This case makes this thing nice and secure and makes it an even better tool than it was. So check out jarheaddiag.com. The link is in the show notes. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. We have got Auto Rescue Tools and Isaac Rodell as a sponsor for this podcast. Hey guys, if you're looking for programming laptops, you want the laptop set up ready to go for programming control modules on vehicles, you need key cutting equipment, you need diagnostic tools, Isaac is your guy. Has all that stuff available for purchase, and the support that he offers along with the purchase has been outstanding. I bought some stuff from him in the past. I got my Dolphin key cutting tool from him several years back. And again, the support has been phenomenal. Helped me out along the way with anything additional I needed to make it work for me. Also, for the month of June 2023, they've got Autel updates for sale. So make sure to check that out as well. Again, that's autorescuetools.com. The link will be in the show notes. Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host today. Today on the show, we're going to talk about infotainment. And what is infotainment? This is basically just a combination of systems on a vehicle that deliver entertainment and information to the driver and the passengers. So think about, obviously, your radio. I mean, radios have been in cars for a long time, and that used to be all there was. And of course, added maybe a cassette player or a CD player. I still have a cassette player in my personal vehicle because it's a 2003. But then we started to add things like touch screens and USB ports and maybe some digital radio receivers, satellite radio, being able to connect with Bluetooth and use telephone features within the vehicle. And really, we've just added a lot to vehicles over the last 15 years or so as far as the audio visual stuff. And we kind of group all this stuff together in infotainment. That's the term that's used to talk about all the different systems that work together. So obviously, these systems can be kind of complex, and they do have problems just like every other system on the car. And I've gone through a string of them recently, so I wanted to talk about it on the podcast. I'm going to talk about 3 different vehicles today. The first one, kind of just some information. It's not really a case study. And then the second 2 are going to involve actual broken cars that were repaired. So the first one that I wanted to talk about was on a 2012 Ford Edge. And on this Ford, I was called in to program an APIM, or Accessory Protocol Interface Module. Basically what this is, it's kind of the central hub for the infotainment on these Fords that utilize the sync system or setup, and that's basically a combination between Ford and Microsoft, and it had a lot of problems. If you haven't run into this, you might at some point or another. But of course, this is the one. It has the touch screen and navigation built in and all the different features. You can work through that center screen, but the APIM module is actually bolted up behind the screen in the center of the dash. Well, these things had a ton of problem, and actually there's a recall through the dealership on a lot of these, so make sure to check to see, because if the dealer can handle this one, you might just want to send it that way. And that's kind of why I'm talking about this. If you are going to take on a job where you're replacing or reprogramming one of these APIM modules in a Ford, there's some things that you're going to need, and I'm going to list that off for you. And there's some time that you want to take into consideration when you go to program these things. So here is what you need if you're going to do a programming event on one of these APIM modules. Obviously, the Ford VCM 2 or 3, and I think you could probably actually even use a 1 on some of these, but the 2 or 3 is the current version of Ford's pass-through, basically. You could say it's their scan tool, but the scan tool platform is actually IDS, and that's a separate purchase. The IDS is a software. The VCM 2 or 3 is the hardware, the link between your computer and the actual vehicle. But you can't do this through J2534. So if you had a CARDAC or something like that, it's not going to work to program this module. Most of the other stuff, well, I shouldn't say most of the other stuff, engine or transmission computers you can do through the JBox. This particularly, you're going to need this VCM 2 or 3, or I guess even 1. Anyways, if you do a lot of Fords, honestly, I don't know why you wouldn't have this set up. Get the VCM 2 or 3. It costs you $1,200 or so, maybe a little bit more for the 3, and then go purchase the IDS year subscription, which is around $1,000, and you'll have full diagnostic capability for any Ford vehicle, along with programming capability. And you can program Fords until you're blue in the face. That one fee is going to cover all of it. So again, if you work on a lot of Fords, I don't know why you wouldn't already have this set up. But of course, you'll need a laptop to work with that, because the VCM doesn't really do anything on its own. It needs the laptop to run the IDS software. Okay, and that's most Ford stuff, that you'll need those things. But in addition to that, if you want to do one of these APIM modules, you're going to need some other things as well. There is a cable set,
It's listed as the CCM Sync Kit. You can Google this. I'll put a link to the show notes. And really all it is a male-to-male USB cable, and it comes with an adapter that goes from a traditional size USB down to a mini USB. Okay, so that's it. That's the kit, but you can order this. It's specifically for programming these APIM modules in Fords. So again, I'll put that link in the show notes if you want to buy that cable, but you can Google it and find it pretty easily. You are also going to need a flash drive with at least 8 gigabytes of space on it. I would start with a blank one, don't have anything else on there. And this flash drive is going to have to be formatted to a specific format in order to work here. And it will depend on the age of the Ford that you're working on, what the format is going to be. It's either going to be an EX FAT or an FAT32 format. Again, you're going to have to figure out what the year range is in order to format this properly. But the thing to remember here is you can't just use any old flash drive. It will reject it if it's not formatted properly. So one more thing you're going to need to do this is, in addition to whatever subscription you have with Ford, you are going to need to make a short-term subscription. I guess you could do a year-long if you wanted this, but to their PTS site, and you can do a 3-day subscription for about $24. And this is going to allow you to actually go to the online version of the IDS, but that is where you're going to actually program the APIM module through, is this online version. If you try to go through the actual IDS program and you get to the APIM module and you want to hit reprogram or program, it's going to just tell you to go to this PTS website and you'll have to go there. You basically don't do any of this through your traditional IDS software. Now, again, it runs it through an online version for a portion of this, but you're going to need that subscription to the Ford PTS site. In order to get this, you can actually go on to motorcraftservice.com, and it is going to be under the service information. That's actually what you're purchasing, is a service information subscription. And then there'll be a link. You click on it and you could log in and access all of these features. There's more to it than just the APIM programming, but you're going to have to access this in order to do that. One other note that I would make, and it tells you about this, is that you need to use Internet Explorer, and they recommend currently Internet Explorer 11 in order to make this software run correctly. Also, I found, and thank you to Matthew Skundridge, he helped me out with this, you need to go into the security options for Internet Explorer and add this website to the trusted sites. Otherwise, when you try to initiate this programming to get into the sync portion, it's going to just reject it and say there's an error. But once you add it to the trusted sites under the security settings for Internet Explorer, you're able to go through. Now, beyond that, really what you need to do is follow the service information, because it actually is pretty detailed as far as how to do this. They have a very good step-by-step process in the service information for programming these APIM modules. And what I'd recommend doing is just print it out if you can, have it on a piece of paper and walk through it step by step. If you don't follow the service information, you're going to be very confused, because it's actually a 3-part programming. It does 3 different updates. One basically just with the scan tool connected, one with a USB cable connected, and then another one through a USB flash drive into the USB port of the vehicle. So it's kind of a clunky process, and I was thinking about running through the whole thing, but honestly, that's kind of boring. My suggestion to you is to go and to read the service info and follow the on-screen prompts. Those are going to help you out quite a bit in this process. The final thing here is, especially if you're doing this for the first time, you want to allot at least an hour of time, if not more, for this programming event. It's probably going to be more your first time because the process is kind of clunky and you're going to have to work your way through it. You might do one of the steps incorrectly. But also, even if you've done this a few times, you want to be able to charge appropriately for this programming event. If I'm going to program this, an APIM module on the Ford in the future, I'm going to be charging more because there's quite a bit more involved in actually doing this. And I know it's going to eat up a good chunk of my time in order to make this happen. You got to sit there and wait for these files to upload into this component for quite a while. So anyways, that's Ford APIM programming. If you have more questions on that, let me know and I can walk through some more of the details, but I didn't really want to make this episode me just reading service information to you. I don't think that's really all that exciting, but get that service information, follow it, and at least now you know what you might need up front, and then you can do some reading and take care of these APIM programmings. Anyways, that's the Ford. That's the first one. Now we're going to move into some case studies with infotainment systems. And for the next two vehicles that I talk about, they're going to use what's called a MOST system. And this is a communications network on automobiles that is specifically for infotainment systems. And MOST stands for Media Oriented System Transport. And this is used on many vehicles, and it was adopted earlier by European vehicles, Audi, BMW, Mercedes. And so it's been around for quite a while, but we're seeing it more and more in the automotive world. And one of the vehicles I'm talking about today is a General Motors. So we're going to be getting familiar with this system. I can tell you that I have gotten familiar with it recently. And the nice part about it is the MOST system, it's a protocol, kind of like CAN. CAN is a protocol that we can apply to multiple manufacturers, multiple vehicles. And generally speaking, it's always going to be the same. Or like, OBD2, that 16 pin port is always going to be the same. And most of the time is going to be very similar. Again, a similar protocol, and it allows for these infotainment systems. There's so much customization that can happen on a vehicle when they order it right from the dealership. Like, oh, I want a CD player, and oh, I want an amplifier, and yeah, I want Bluetooth connectivity on this, or I want a satellite radio, or I don't want that. And the way this network's constructed, modules can basically be added or taken off of this network pretty easily. Now, not necessarily in an active vehicle, but when they're constructing the vehicle, they have the network potential to just add a bunch more of these components onto the network or leave them off, and the system's able to configure itself relatively easy. I mean, I'm sure the work going into engineering this stuff isn't easy, but it's able to figure out, okay, these are the modules on the network. Let's go. Let's do our thing. A few more things about the MOST network before we get into this. We see fiber optics used in the MOST network a lot of the time, especially in the European stuff, but it is not always fiber optic systems. General Motors actually uses a copper wire in order to transfer data between modules. But in the fiber optic system, it is exactly that. It is a fiber optic tube, if you will, that it has an LED. It's going to flash a red light in order to transfer information between modules. So something to consider is if we're dealing with a fiber optic, we can't do the same tests on a network that we are used to be able to doing with, let's say, a CAN network. Can't hook up our scope to one of these fiber optic CAN bus networks, at least not with anything I'm aware of. Who knows? Maybe there's an LED attachment for the Pico out there that I'm not aware of. But anyways, conventional methods are not going to work here. Please don't pierce the fiber optic cable with your scope lead. It's not going to end well. The other thing about this is that it's set up in a ring topology, which basically means the network's a big loop. And communication is going to flow in one direction on this loop. And there's some variance to that, but I keep saying most of the time we're going to see communication work in one direction. But that also presents the possibility for a break in this network to cause the whole thing to go down. And that definitely can happen. There is a master module on these most networks, and this module is basically going to be in charge of timing and communication throughout the network. And there's going to be an enable circuit that we'll see in one of these vehicles. That master module is in charge of that enable to say, hey, everybody wake up, start talking, start transferring data throughout this ring network. All right, so with that all out of the way, let's get into the vehicle here. And this was a 2005 Audi A6. So, I mean, this thing's 16 years old. So it's definitely not new technology, especially on the European side of thing. But I've said this before, I don't do a ton of European work. There's just not that many vehicles in the area that I'm at, but we still do see some, case in point here. So the problem with this Audi, I was called to the shop. They said the screen, which is a touch screen that's used for the infotainment, is just blank. And the shop owner told me that this was just an all of a sudden thing. The screen just went blank. It's in the shop, and they would like me to figure out what's going on because it's kind of beyond their abilities. So something to know about a lot of these most systems is that if there is a break in the network, or if there is a failed module in this ring, in this loop, it can cause, most of the time does cause, the whole network to go down, and your screen, which is really the most common interface for the user of the vehicle, is going to be blank. It's not going to be working if there's a fault in the network. So as soon as we see this on one of these vehicles with the most network, first thing that we're going to be thinking about is, okay, there might be a module failure within this network or a break in the network somehow or another. So I do a all system DTC scan, which is a good first step to do on most vehicles. Gosh, I'm going to keep on saying that. No pun intended there. And what I find is, it's an older Audi, so there's a gazillion codes in the vehicle, but the one that matters to me is in the data bus onboard diagnostic interface, which I'm just going to call the gateway module because that's what it is. In the gateway module, there is a code for most bus network failure. Well, okay, I guess I could have guessed that based on the status of the screen. That's not working, that there's a most bus failure, but here's where a little bit of reading and research on the system, this is going to help me out, identifying that the gateway module has flagged a fault for the most system. Is it tied into our most network? And in fact, it is. And it is the only module on the vehicle that can communicate with the scan tool to give us information about the most bus. This is basically the link between our scan tool and our infotainment system, is our gateway module, or the data bus onboard diagnostic interface. So again, after doing a little bit of reading here, I find that there's a scan tool function that will work with the gateway module to do a diagnostic of the most bus network in real time. So really, it's just going to have the vehicle, have the gateway and the most system check itself and see what's going on, and it will report something on the scan tool. And this was actually really, really helpful. If I didn't have this function, I probably would have been pretty lost on this vehicle, to be totally honest. But I did this with an Autel, so you can do it with an aftermarket scan tool. You don't have to be afraid of these European vehicles. I found Autel does pretty well with the Euros for most diagnostic stuff. Not everything, but in this case, it worked out pretty well. And what this test is going to do, it's going to give me a layout of who is on the network, number one, because there's a lot of different options for modules on this thing, but also who's present and basically where the fault is, or who has a fault on this most network. So I go ahead and I run this on the scan tool, and it gives me the layout of 8 different modules on the vehicle within this most system. Okay, well, at least now I know which ones are equipped on the vehicle. And of course, that's an important thing to know with a network communications issue, whether it's most bus or not, and you have a communications fault, sometimes it can be tough to tell what's actually present here, what actually exists on this vehicle. Well, this lays it out for me pretty nice. And it's going to tell me where the fault is. And hopefully this will help me identify, okay, it's this module has caused a problem, or the brake is, between these two modules. That's another possibility. But I have 3 modules that read fault when I run this test on the system, which that strikes me as kind of odd. And I'm trying to think, I'm not super familiar with most systems. I just haven't done a lot with it. Honestly, the 2 in the last couple of weeks that I've dealt with is the majority of my experience actually dealing with these systems and not just reading about them. So I'm thinking, well, 3 modules that indicate fault, and I don't know, is fault no communication at all, or is that they're flagging a code for performance in the system? I don't really know what fault means, but are they all physically on one section of the ring, of the loop? Again, I'm not 100% sure, so I think at this point it's good to, again, go into service info and do a little bit of reading on where to proceed next. What should I check next? Oh, and I should mention the 3 modules. I'm not going to list off all 8 modules for you right now, but the 3 modules that listed fault were the navigation, the front display, which is actually, your screen, and it has a module connected to it to run it, which is behind the glove box, and the digital sound system control module. Okay, so these are the 3 modules of the 8 that indicate fault when I run this diagnostic test on the most bus network. So what I'm considering here after doing some reading is maybe there is some sort of fiber optic break in the network. And if you want to diagnose these fiber optic systems, you're going to need what's called a most bus loop, or I've seen it listed as a most bus repeater. But really all this is, it's a thing you can buy off of Amazon for, again, pretty cheap. I think it's under $20, and it is just a most bus loop, and it is a fiber optic loop that you plug in place of a module on this network. And because of the protocol that most uses here, this actually works on multiple manufacturers. It's not just Audi. You can use this on Mercedes and BMW, and I think Porsche was listed as well. So a number of European vehicles, this tool will actually help you out. And I actually had this tool. I'd purchased it a while back because I saw it was cheap, and I thought, well, maybe I'll need it at some point or another. So luckily enough, I had this in my van. And so I'm thinking, okay, well, why don't I just start with one of these modules? Because again, I'm kind of experimenting here as I go through the diagnostic. Why don't I start with one of these modules that reads fault, and I'm going to put this loop in place of the module. Now I'm only unplugging the fiber optic portion, but I'm going to basically just bypass that and complete the ring, or complete the loop going in and out of this module. So I do that, and I wanted to look at the physical location of these modules that read fault too, because, well, maybe that'll help me understand, if there is a break and not necessarily a failed module. Because a failed module here, it's kind of going to act like a break in the loop in the network. And again, I'm not sure why there's 3, but let me just try one and see what happens. Maybe I get another one back. Maybe something changes. Maybe it'll lead me to the right place. But again, back to the physical location of these components. I know where the front display is, obviously. I can see it, and there's a module behind the glove box. But the other 2 are in the trunk. And luckily enough, they were very easy to access. Again, this is the navigation unit, and it was the digital sound system control module. There was actually another control module. I think it was a CD changer that was there. That read okay. But anyways, these modules are stacked up on the driver's side of the trunk behind a panel. They're very easy to access, takes almost no effort. So let's give this a try. And so I unplug them, I bypass, I tried the navigation first, I ran the test again. Of course, the screen's still blank and it comes up with the same answers. So then I'm right there. I'll try the digital sound system control module, bypass that. Same result. Okay, so at this point, do I want to drop the glove box and get to my front interface control module? I don't know about that just yet, because I don't know, things don't really make sense as far as a break in the network. I've got 2 of them in the trunk. I got 1 of them up front. Bypassing them doesn't seem to change anything, and things aren't just adding up. And I know I'm not really experienced with these systems just yet, but it doesn't really make sense that there'd be a break in the network causing the faults that are present. And it also doesn't make sense there'd be 3 failed modules. I mean, I guess it's possible. It's a 2005 Audi, but according to the owner of the shop, this thing was working just fine, and then it just went out. Okay, so whether that's true or not, I don't know. But here's where I go with something like this. And you can apply this to a lot of different areas when you're doing diagnostics, is you have multiple failures or multiple problems that are presenting themselves. And it's totally possible, definitely happens, where there are actual multiple faults. There are more than one thing wrong with that vehicle. That happens all the time. But if it's something that just occurred, okay, the car is working fine until this point, and now blank, blank, and blank don't work or are malfunctioning. What I like to do in this case is just pick one path, pick one thing that I go after, and I figure out why that one component or why that one thing is happening incorrectly. And a lot of the time it leads me to the solution that fixes everything. And this has helped me out so much in the past, whether it's infotainment or just about anything on the vehicle, especially when it's electrical or computer related. Pick one path. Jim Morton says, pick your funnel, but I want to identify one thing and say, okay, this isn't working. I'm going to go after this specifically instead of bouncing around, chasing my tail, going back and forth between different components. And that's what I got here. I got 3 modules that don't appear to be working. Maybe a break in the network somewhere, but I am going to just figure out one module, okay? And when we consider one module, it becomes a little bit more easier to process and to figure out my path. So what am I going to do if I have a module that seems to be not working? Of course, I'm going to check powers and grounds, okay? This is now my thought process. I kind of took a breath, sat back. All right, how do I want to tackle this? And that's it. Let's check powers and grounds. And what's the easiest first step to check powers and grounds? Let's check the fuses. And so that's what I do. And I picked the front interface control module because I was in the driver's seat and I had to go over to the passenger side. There's a fuse panel on the right side of the dash there. You open up the door, you can get to this fuse panel, and I checked the fuse, and it's fuse 10 on this fuse panel, and it was blown. Okay, so I replaced this fuse and the screen doesn't come on yet. But I ran my test again on the network and the front interface control module no longer came up with a fault. Okay, so maybe I'm making some progress here. Let's check the other modules and do the exact same thing. Now these other 2 modules, it's fuse 8 and fuse 7 in the rear fuse panel, back inside the trunk, but again, easy enough to get to. And guess what? Wouldn't you know, both of those fuses are blown. So I put those 2 fuses in there, and no sooner did I do that do I see my screen light up and say, I think it was like Audi media system or something like that, and the radio starts playing, and I'm like, sweet. It was just some fuses that were doing this. Now, I did have to ask myself, well, why would 3 of these fuses be popped all at once? I looked at the diagrams, and I actually studied this after the fact too, and I didn't see any correlation as to what these 3 circuits had to do with each other besides the fact that all 3 of these modules are on the MOST network. So I wanted to question the shop owner again because I feel like I'm missing some information here. I mean, 3 separate circuits blowing fuses at the same time seems very unlikely. And question him, and he questions the customer, and come to find out, and of course we never get all the information that we need up front, No matter how much we ask, and maybe I just got to grill people more, I don't know. But come to find out, the vehicle had been left on the side of the road. And it's winter here in Minnesota right now, and we have big snowstorms, and they live down in the cities. And if there's a big snowstorm and you live down in the city, you can't leave your vehicle on the side of the road, especially when the plows are coming by. Here's what happens if you do that. Your vehicle gets towed, and it gets towed away very quickly. Well, when that happened, the tow truck actually ripped the front bumper off of this Audi. Okay, now somebody put the front bumper back on, but I guess they had ripped some wires out when this happened. And again, it had been put back on, and I don't know how well the wires were fixed. Of course, you have different components wired up to the front bumper there, but they said after that, that's when the radio stopped working. Okay, well, again, I looked at all of the circuits to see if there's anything that correlates with that front bumper. To be totally honest, I don't see anything based on the diagrams. We took a look and we didn't see any wires that were shorting out or anything like that. Obviously, the stereo worked. The radio was working good. The fuses didn't blow. I told the shop owner, I was like, who knows what happened when this thing got towed or how these popped? I'm not really sure. I don't have a good answer, but I do know that they're not blowing right now. So give me a call if they pop again. It's been a week or more, and I haven't heard back about the vehicle. So, although I don't have a 100% accurate explanation as to why, I think it has something to do with the bumper getting ripped off and the car getting towed. Just my guess, but I guess it would have been nice to know right away. I don't know that that would have directly led me to fuses for modules, but maybe I would have gotten there a little quicker. But anyways, we had 3 modules that had no power to them. So that basically shut down the most network. And I think only one module with no power to it would have done the same thing until maybe if we bypass that single module. But with 3 down, my most bus loop didn't really help me because I only have 1 loop and I still have 2 modules that were failed. So just something to consider. It's probably a unique scenario that you might not run into, but it did help me learn a little bit about the system. All right, on to the next one. This is a little bit newer. This is a 2014 Chevy Silverado. And a Chevy Silverado is a little bit more in my wheelhouse. I work on a lot of GM vehicles, so I kind of expect to see more of this. And in fact, I've actually been to a class that John Thornton put on where he covered the most system in GM vehicles. Awesome. Now, it was a couple of years ago, so I hadn't actually worked on any of these systems after that class. So I definitely had to jog my memory here, and I ended up talking to Matt Fonslow on this because he was sitting in the same class, and we both had our workbooks from that class in order to kind of remind me a few things about this system. But the fact of the matter is I had taken the time to go to one of these professionally led classes. Of course, John Thornton's one of the best, and he has really, really great information. So I can honestly say being able to make a confident call on this Silverado was because I took that class. And I'll say it again as we move through this diagnostic, but go to these training courses. They're worth it. Okay. Once you finally get to that vehicle where the information you got in that class allows you to be confident in your call, well, that just paid for the class. So here's the problem. Screen's blank. Bet you could have guessed that. That seems to be what happens when these most bus systems fail. But I actually wasn't called in for a diagnostic on this one. I was called in to do a programming on the radio in the Silverado. So there is a TSB that actually spells out exactly what this truck was experiencing. A blank radio screen, no chime when you open the door. Obviously, that's done through the speakers on this one and the audio system. So our most system or our audio system is down. And the fix is to do an update on the radio. And I go in, I connect, because I'm not there for a diagnostic at this point, but I connect to the radio. I can talk to it through the scan tool, which is a good sign. Or I'm using the MDI2 and GM SPS, and I check the software level in the radio, and I see that there's an update, and in the update in SPS spells out right there for screen going blank. Okay, so it needs the update. That's what's happening. Let's go through with this. I should also note there was no codes in the radio, and obviously I can communicate with it if I can pull a software level. So I go ahead and do this. Warning on this one, kind of similar to the Ford. This is a 45-minute process just to update this radio through GM SPS. On this particular truck, I did not need any sort of USB, but do be warned, there are some newer GM vehicles that you are going to have to do it through a USB as well as GM SPS. Read your service information. This one didn't, but it still took 45 minutes. So the next time I go to do one of these, I need to allot for that amount of time and charge appropriately for the time it takes to reprogram this control module. But we wait and we wait and we wait, and it finally gets to the final progress bar. It's at 1 second for the update, because GM will put a little timer on there as the bar moves across. It's sat at 1 second for about 35 seconds, which kind of tensed me up a little bit. I'm like, okay, what's happening here? But it finally did go through. It completed, said good to go on the update for the radio. Okay, cool. And we do a key cycle and we have the exact same thing. Screen's blank. Still communicate with the radio. No codes in the radio, but screen's blank. So now I'm going to switch into diagnostic mode. The guy wanted me to look at it, figure out what's going on, because obviously the update didn't do it. So a little bit about GM most circuits. They are not fiber optic, at least not in this application. They are going to use a copper wire as medium for transfer of data between these modules. Now it's still set up in a ring style. It's still using the same protocol, but it is copper wires between these modules. They're going to be a twisted pair, but don't confuse this with a CAN bus network, because we can't apply a lot of the same things from a CAN network to this MOST network. One of the most important things to remember about that is in a CAN network in GM, we daisy chain the network so it looks like there's an in and an out, but physically the network wires are connected through the module. They're just shorted through the module. So, if we were to ohm out just one side of a CAN network from one end to another, we should see continuity. Now, I don't know that you'd necessarily do that, but if we did, we'd see that. In a MOST network, in a GM that uses copper wires, there's actually a separation. Okay, so these network wires will go into one module and then they will come out of that module on another two wires, but there's not a physical connection between those circuits, meaning that if a module goes offline for whatever reason, maybe a fuse is popped, it is going to create a break in that network or a fault in that network. And it's just something that are important to remember about these systems. It's the same with the fiber optics, but I really wanted to make that clear on this copper wire setup that we see in GMs. Now, in addition to the actual communication circuit, there's also an enable circuit. And this enable circuit is going to be turned on by the master of the MOST bus, who in this case, and from what I read, most General Motors, most systems, it's the radio. The radio is the master for this circuit. He's in charge of enabling communications and is kind of the central hub for everything that's going to happen in this network. There are 3 other modules on this particular vehicle, but remember, it's all based on RPO codes and the options for that vehicle. But in this case, I only have 4 modules. It is the radio, the instrument panel cluster, the CD player, and the human machine interface module, which I have always found to be a funny name for a module, but that's what they call it, a human machine interface module, which is behind the glove box. So 4 modules on this network, and I did do an all system DTC scan, and the only code in the vehicle that had anything to do with what we were dealing with was in the human machine interface module, and it was for MOST circuit performance. Okay, again, could have expected that, but odd that the I'm going to call it the HMI, odd that the HMI module had a code for most bus performance, but the radio has no codes. I mean, he's in charge of this whole thing, right? And we can communicate with it. Now, I couldn't communicate with my CD player, but the CD player is on the most bus only. The HMI, the radio, and the instrument cluster are on other networks on the vehicle, so my scan tool has a backdoor into those modules. And not that the scan tool is on the most network, but what I'm saying here is the CD player, if the most network is down, the CD player has no means of communication to the scan tool, which is the case here. So we don't want to immediately think that the CD player is the failure here. Who knows, it could be, but it could also just be a most network failure, and it takes the CD player's ability away to communicate with the scan tool. So, and again, this, I mentioned it before, but credit where credit's due. John's class is really what allowed me to have the information I needed on this system. And so some of the stuff that I'm explaining here, I'm not going to go through all of it in detail. I want you to go take these classes, but it's specifically because I went to the training that I even knew about this stuff. So the radio is the master for this system. And one of the things that we can do, because he's in charge of the system, he's in charge of the enable circuit, and he's also in charge of presenting some data PIDs that give us information into where there's trouble in the network. Kind of like our gateway module did in that Audi, but it's going to be set up a little bit differently. The data PIDs that are going to be helpful to us are going to be the most bus network breaks, and it will actually show us a number of how many times it's identified a break in the network. Also, it is going to show us all of the modules that are on the network, and it's going to number them in rotation going clockwise on the network. So 1, 2, 3, 4, or I think it starts with 0, 0, 1, 2, 3. If there's a failure in this network, there's a break in the network, there's a failed module, communication will actually be reversed, and it will use what's called a most surrogate master node. This gets pretty complex to explain without a diagram. And again, I'm not going to get too deep into this part because you should go take the training if you want to get good at this. Or the other thing you can do is there is free information out there on the actual most protocol. The company puts it out there. You can read through the 337-page manual and learn everything you want. Or you could go to a training class where it is presented in a very clean manner that's easy to understand. That's what I'd recommend doing. So I'm not going to get into the details here, but there were data PIDs that I could use in order to tell me what's going on with this network. But in this case, it didn't really help me. It said most bus ring breaks 0. It also said for the modules that it was supposed to recognize on the network that they weren't there. It said unrecognized for all modules. It didn't see that there was a CD player, that there was an HMI, that there was an instrument cluster, basically nothing on there. And I was thinking to myself, I'm like, boy, I should have checked this before I programmed it. Did I do something wrong programming here? And I was thinking, okay, hang on, before I go any further with this, I want to just do my capacitive discharge, which has helped me out quite a few times on other problems, just in case there's some sort of initialization that I missed when I did the programming event. So I do that, doesn't change anything, but I thought I'd just take this step. I kind of thought out of it at that point. I had cycled the ignition after the programming, but let's just do this. Of course, it didn't fix anything, didn't change anything. I still got the same data PIDs. So in this case, the data PIDs didn't really help me and didn't indicate that there's a specific break in the network. And again, I still have no codes in this radio. I would expect there to be some code if it's not doing anything on this network. But this is where we're going to bust out the scope and do some checks here to see what's going on. Now, the advantage to this copper wire system is we can actually scope the network and see some signals. Now, analyzing these, I don't know how easy that is because this communication is very fast. But here's the deal. You should see something on these network wires. I do this. I cycle the key, in order to get the system going. nothing on either one of these wires. There is nothing. Okay. I checked to make sure that the network wasn't shorted to ground in one point. Now, again, it's not all physically connected, but I did check like right out of the radio on both sides of the network. There's kind of an in and an out. Nothing. No short to ground, no activity. They're not shorted to each other. Is another thing that I checked. And the other one thing that I want to check here is the enable circuit out of the radio. And what this enable circuit is every module on this MOS network puts out 12 volts, keeps it high, and then once you turn the key to the on position, the radio should enable the communications for the MOS network by pulling that circuit low for 100 milliseconds. Well, that never happened. No matter what I did, I could not get that enable circuit to go low. I looked in the data PIDs for the radio. It recognized the key position because it gets this over the one of the other networks on the vehicle. So it saw that the key was in the run position, but it was not enabling communications. I actually tried enabling myself by pulling it to ground quickly. Didn't change anything. Still no communications, nothing on this MOS network. The one thing I did try here, because at this point I have the front screen off, I'm accessing the radio, which is in the center of the dash. I did want to try just bypassing a module. Now, another advantage to this setup is you don't need a special adapter in order to bypass a module in this network. I don't know if this is going to help me or not, but I'm right there. I want to give it a try. And so all you got to do is jump two sets of wires together. There's 4 wires. There's an in and an out with a twisted pair, and we're just going to jump them together. You could say the high and the low if you wanted to, and that's eliminating that module off of that network. So I tried the CD player because it's right there, and I even tried the radio, although I didn't think that was going to help me because he's the master of the network, and neither one did anything. So really everything at this point is kind of pointing to the radio. Why isn't the radio enabling the MOS bus? Why isn't there any communication? Why isn't it setting any codes saying that there's a issue here? One thing I did do is check powers and grounds to the radio. We want to do that. And in doing that, I actually noticed when I would unplug and plug in the power source to the radio, it would enable the MOS bus real quickly. But then there was no communication after. So again, everything is pointing towards the radio here to be the fault in the system. And again, I talked to Matt Fonslow, and he kind of helped me out. So again, credit to him as well, just to have the confidence based off of the information that we had from the class that, yeah, the radio's where we want to go. Ordered a new one from GM. It's only $200 or 220, so really not that bad. Did the programming event again, which was another 45 minutes. Waited on that last 1 second, just like the first time. But actually, as soon as we plugged in the radio, even before we programmed it, the screen was on. So kind of had a good feeling at that point. And then once it was programmed, everything worked. Radio, audio system, good to go. So I thought that was pretty interesting how that all worked out. And hopefully it gives you a little bit more understanding into some of these infotainment systems. But if you want to learn more, get out there and get some training. That's where you're going to learn about this stuff before you're tossed right into the middle of it. I hope you enjoyed that. Hope you learned something. Other than that, let's get out there, start fixing the world one car at a time.